Every architecture student knows this exact feeling: a fresh studio brief, an empty site plan, and a completely blank drafting desk. The pressure to produce a definitive form out of thin air is paralyzing. We often wait for a sudden flash of inspiration. We sketch ungrounded shapes, hoping a valid architectural mass will simply appear on the page. But relying on arbitrary intuition is inefficient and unpredictable. The alternative is active syntax. Instead of pulling shapes from a void, we start with a definitive mass and systematically act upon it. Form becomes the result of specific, deliberate actions. This methodology treats architectural form as a system of objective operations, where the final result is a record of specific, traceable choices. To execute this methodology, we need a vocabulary. This diagrammatic bounding box is the starting point for operative design, a catalog of spatial verbs by Anthony DiMari and Nora Yu. The authors map out every major form-generating action into 5 distinct operational families. We will take a primitive, unarticulated block and apply these operations sequentially. We will observe exactly how simple actions generate complex architectural proposals. While this theoretical explanation proceeds in formal Marathi, we will retain the standard English industry nomenclature for the specific architectural verbs. Internalizing these 5 operational families provides a structured entry point into the design process, allowing the student to initiate work on any site by acting upon a base mass. The first family is subtractive operations. This is the strategic removal of mass to carve out usable space within a solid block. Removing volume serves strict programmatic purposes. It defines necessary light wells, establishes interior courtyards, and clears definitive circulation paths. Looking at this animated diagram, we see the base mass. We carve to hollow out a central void, and we cut to cleanly slice an entire corner away from the primary geometry. We notch the geometry to create a sharp, angular indentation on the edge. Then we drill, driving a deep, cylindrical void straight through the center. To break the continuity of the form, we split the mass into 2 entirely separate halves. Finally, we erode the rigid right angles into a staggered, irregular edge. Ultimately, the act of subtraction shifts a building from a dense, impenetrable object to a highly permeable, habitable environment. The second family encompasses additive and transformative operations, the process of attaching material and altering the relationships between volumes. When project requirements dictate a larger footprint, these actions expand a building's square footage to meet complex programmatic demands. On this primary gray volume, we extrude by pulling one face outward to extend its length. We then offset, creating a secondary boundary line that expands proportionally outward from the original shape. To create intimate spatial relationships, we nest a smaller volume completely inside the primary mass. By shifting it outward, we overlap the two, resulting in a partial intersection. We intersect by pushing a distinct, long rectangular volume entirely through the primary mass. Conversely, we embed a smaller shape by sinking it flush into the exterior surface. Strategically adding and transforming material allows architects to scale up a building while strictly maintaining its underlying structural logic. We now shift our focus from heavy volumetric massing to the manipulation of lightweight planar elements. These specific operations are strictly utilized for defining building envelopes, dynamic facades, distinct roof structures, or floor plates. Starting with this flat rectangular plane, we apply a fold to bend it sharply in half. By repeating the action, we pleat the surface into an accordion-style zigzag texture, establishing structural rhythm. We warp the planar geometry, bending it smoothly along a sweeping curve. We then taper the plane, dramatically narrowing its width toward one specific end. We shear the surface by sliding opposing parallel edges laterally in opposite directions. Finally, we stretch the entire surface, elongating it continuously along one axis. Applying these planar operations translates a static facade into a dynamic, structurally sound building skin capable of complex environmental responses. When a large site program demands broken-down masses instead of a single building, we face the challenge of multi-volume interaction. Observing these 2 adjacent cubes, we rotate one, pivoting it 45 degrees on its central axis. We shift the other, sliding it laterally off its center point. We stack the volumes, resting them directly on top of each other to manipulate vertical hierarchy. We then cantilever the top cube, sliding it horizontally to overhang without direct underneath support. By physically meshing the intersecting geometries together, we interlock the volumes. Finally, we cluster them, multiplying the masses into a scattered, multi-unit site arrangement. Relational operations establish the project's hierarchy, direct site wayfinding, and dictate an active dialogue with the surrounding context. Massive, monolithic blocks can be oppressive and uninviting. They lack human scale. Fragmenting operations are essential tools used to break down an intimidating silhouette into relatable proportions that a pedestrian can comprehend. In this diagram, we fracture a singular monolith, shattering its smooth continuity into irregular shards. We then pixelate the exterior, breaking the surface down into a dense grid of small, protruding voxel cubes. We puncture the dense geometry, piercing it entirely through with deep voids. We then splay the structure, dramatically spreading it outward at its base. To create highly organic silhouettes, we twist the splayed structure, spiraling it aggressively upward along its vertical axis. Finally, we inflate the hard edges, ballooning them outward to form an overpressurized shell. Strategic distortion transforms a hostile mass into a highly articulated architectural intervention that responds accurately to human scale. If we analyze highly sophisticated contemporary buildings, we find they are not the result of unexplainable genius sketching. They are produced through the rapid, sequential layering of these simple verbs. Watch this process. We take a pristine base block and we apply our first verb, split. We shift the halves vertically against each other, cantilever the upper half outward, puncture the overhang with large voids, and pleat the front face. This final, highly complex architectural form is entirely traceable, step by step, back to 5 objective decisions. For students at the D.Y. Patel School of Architecture, this methodology solves a critical problem in the studio jury, relying on subjective defenses. Instead of vague aesthetic preferences, an operational defense relies on the specific, traceable actions performed on the building mass. A defensible argument states exactly what was done and why. The mass was split for circulation, shifted to optimize solar orientation, and pleated to provide facade shading. Mastering these specific vocabulary verbs is synonymous with mastering the actual generation of architectural space. Ultimately, adopting this defensible methodology is what successfully bridges raw, unpredictable student intuition with the structured, rigorous demands of modern professional architectural practice.